Test, test. Hello. Hi, everybody. If anyone's on in chat, could let me know how the music levels are, if it's too loud, too soft. That'd be rad. Hey there, V.E. Kruger. Alright, you guys. I found my hat that has the shortest bill. I think this should help today. This will solve some of the technical issues that we've had. I don't know if you can see. There's a little bit of a microphone peeking right there. We're just gonna push it a little bit. Maybe that'll help. I don't want to touch the mic too much because it might be loud. There we go. A little mic pixel. Music's a little soft. Let's turn it up a little bit. A little better? It's so hard to tell. All right. I was having some computer problems. I was getting no internet down here. Don't know why. Just had to restart. So we're getting ready. I have to remember every week, like, what in fact the hell am I doing with this project? There's a lot of different types of things that I do. Oh, that's fun. You were putting it through the paces, though. There's a lot of physics being calculated during your stream today. So I can kind of understand why your computer would just be like, nope, I'm tired. Calling it quits. That was a really fun stream, though. Thanks for doing that today, earlier today. Okay. What do we got here? So where were we? We just started Circuit 2. Yeah, I think we just started Project 2. Cool. That's good. Is that game multiplayer, by the way? Not that any of my machines could run it, I think. But where were we? Let's take a look at our last project. Just single player. It'd be hard to have it be multiplayer because it's such specific kind of puzzles too. Seems it could be touchy. I'm gonna get out some of my other tools that we might need today. Screwdriver. A pencil for pointing at stuff. Okay, so given that I'm starting Project 2, I think the first thing to do is to remove everything from Project 1, right? I think that's the thing to do. And actually, let's demo Project 1 really quick. Just for anyone who was not able to turn in last week. So Project 1 gave us it's a photo, so it's a nightlight kind of thing, so there's a photo sensor right here. If I go here so we can see. There's a photo sensor right here, so once this goes dark, it turns on the LED. Then there's a potentiometer here, which changes the color of that LED. Which is pretty neat. And just to show you the code for that, I have to open up the code, wherever I put that. Let me just type in IDE, huh? So, just booting up this thing. So it's this project here, Project 1D. So this is all the code that runs what we just did. So it has a couple of inputs. So we're getting an input from the photoresistor and an input from the potentiometer. And then it's outputting to this LED, sending different kinds of signals. And it's not just outputting it in a in a standard fashion, it's not like just like on or off, true or false. It's actually a pulse width modulation, which is something that I learned a lot about last week, which basically means that it turns on and off in a certain amount at a high frequency that gives different values. So you can get like smaller or larger amounts of power to a specific output, depending on your pulse width modulation settings. So in the picture-in-picture here, so these are the pins right here for, actually these are assigning the pins to red pin, green pin, blue pin over here. And I'll do one of these so you can see. So you can maybe see, I doubt you can actually see that. And then we can change the values that get sent to that along here. So we have, here's our green, yellow, blue, magenta, and all those fun things. So really cool project. I learned a bunch. I recently went to Micro Center for something, and I had to glance at all of the like microcontroller stuff, and I was like, oh, look at all these sensors. I'm getting excited about it. I need to finish this before I buy any other sensors. But I'm getting pretty excited about this kind of project. I'm starting to understand the inputs and outputs a little bit better and how to control them. So I'm excited for project 2. So before we really get any further on that, we're gonna nullify everything here. We're gonna start from scratch. So I'm pulling out all of my leads. I'd much rather start from scratch on everything as opposed to adding on, just because then it gives me more practice using a breadboard and all that fun stuff. So we're just taking out all of our jumper cables here. We'll put them nicely back in our bag. Which takes a lot of motivation to do this. Put this in the back in the right spot, but I know it will be better in the long run for me to put them in the right spot. To make a habit of that. I'm really very much looking forward to doing these streams every week. I'm having a blast doing these projects because it's actually interesting. You know, I'm getting to a point in a lot of the work that I do that there's not a lot of problems that aren't already solved. So it's kind of, you know, or that I can very quickly solve just off the top of my head. So it's really nice to experience something that I'm really pretty new at. Is anyone else working on something that's a little outside of their comfort zone right now? Some new piece of learning that they're starting out, or embarking upon. I like this tune. This is good. Chat overlay. I do. Well, I bet my chat overlay doesn't work because I changed my username. I wonder how that's functional. So I've now officially changed all of my channel stuff to Grant Makes from Dr. Devington. And it's kind of nice to have everything all synced up. Working the same way. Playing a little Dead by Daylight, which is very outside current comfort zone. Yeah, that game is terrifying. Not so good at it. That's cool though. Andy plays a lot of that, right? Andy or does Ajax play that too? Can't remember. Okay, we're gonna read this project out. Let's see what this says. Actually, let's just do overhead. I know one of those guys plays it. Oh, that's awful to try and read. Nope, that's not gonna work. We're gonna put this up over here. Okay, so in Project 2, you will venture into the world of buttons and buzzers while building your own Simon Says game. Simon Says is a game in which LEDs flash a pattern of red, green, yellow, and blue blinks, and the user must recreate the pattern using color-coded buttons before the timer runs out. That's cool. I'm awful at those. Oh, that's cool. Hey, Zetwilder. I hear that streaming Persona is quite the undertaking. There's quite a bit that goes into that. Well, thanks for joining tonight. Always a pleasure to have you here. Okay, so some new components. The buzzer. The buzzer uses a small magnetic coil to vibrate a metal disc inside a plastic housing. By pulsing electricity through the coil at different rates, different frequencies or pitches of sound can be produced. Attaching a potentiometer to this output allows you to limit the amount of current moving through the buzzer and lower its volume. Cool. Oh wow, 400 hours. That is an incredible amount of time. Goodness gracious. I don't know if I have that in me for games anymore. Yeah, focusing for 400 hours is a lot. That's cool though. It's nice to be able to really sink into something like that. Those are really story rich, aren't they? Like the characters are quite engrossing in those games. Another new concept we have is the reset button. Redboard has a built-in reset button. This button will reset the board and start code over from the beginning, running setup then loop. That's cool. Tone function. To control the buzzer, you will use the tone function. This function is similar to pulse width modulation in that it generates a wave that is of a certain frequency on the specified pin. The frequency and the duration can both be passed to the tone function when calling it. To turn the tone off, you need to call no tone, or pass a duration of time for it to play and then stop. Unlike pulse width modulation, tone can be used on any digital pin. I wonder how. I don't know if we have Zen on the chat tonight. But if he were here, I would ask Zen, how can you have different frequencies on tone, but not using a pulse width modulation pin? Fair amount of teen. So, referring to Persona 5, Zetwilder says, for the most part, yeah, it's a fair amount of teen angst with mature problems and sometimes dark plots. Okay, that's cool. Arrays are used like variables, but they can store multiple values. The simplest array is just a list. Imagine that you want to store a frequency for each note of the C major scale. That sounds cool. We could make 7 variables and assign the frequency to each one, or we could use an array and store all 7 in the same list. To refer to a specific value in an array, an index number is used. Arrays are indexed from 0. For example, to call the first element in the array, use array name 0. To call the second element, use array name 1, and so on. 0 indexing numbers. Got it. So glad that I tackled that whole concept like a year ago. Really super duper helps understanding 0 indexing. Ready to start hooking everything up. I don't know, am I? Okay. Check out the circuit diagram and hook up table below and see how everything is connected. Okay, so it looks like all we're doing is really putting out from pin 10 as our positive, digital pin 10. We're just hooking up the potentiometer to the buzzer. Excuse me. That's cool, we can do that. That's simple, right? Here's our little bag of treats. Here's a buzzer pal. Oops, a couple other things fell out. What is this? I'll have to figure that one out later. Hope everyone's having a nice weekend. I got to spend a part of the day outside, which is always nice to do. Okay, we need 3 black wires. And a yellow wire. Oh, that's cool. Oh, that's great. 2 awesome things. So, the Kruger bought some suet, and I apologize if the chat module isn't working in OBS right now. I'll fix that. So V. Kruger bought some suet for the birds, which that kind of sounds like a good idea. I should maybe do that. And Zet Wilder had a very super chill and enjoyable weekend. What's not to like about that? That's awesome. So we're hooking up the potentiometer to, so let's zoom in. Okay, so we're putting our potentiometer, let me move this so I can actually see my diagram. Potentiometer is going at B, 1, 2, and 3. I don't know why they chose to start at B instead of A. Doesn't make any sense to me, but you know, we're gonna follow the instructions. Yeah, I think that's wrong. It's gonna go at A, 1, 2, and 3 because I want the extra space. Buzzer is gonna go at H. It's not really the right size. I've had a really nice time. Oh. So this buzzer has polarity. I didn't realize that. But just when I was glancing at it just now, I noticed something, and it does warn me in the book, but I didn't read that part yet. As I noticed a little tiny plus and minus on here as I was having to bend these pins a little bit to get them to fit. So we're going to have to pay attention to our polarity. So we want the positive to go at the top. So positive is going to go at H1. Negative is at, did I put that in H? This is like not enough room how they designed it. This buzzer is like huge compared to their diagram. So we're going to hook our positive F over to pin 10, which 10 has a tilde on it. So they say like it's not actually using pulse width modulation, but they're still having me go to a pulse width modulation pin. So I don't know about that. Wondering what's the deal. Goes to the ground there on the chip. Kind of hard to see, but so I just plugged that into ground there, and the yellow wire is at 10, which has a tilde on it, which means that that's for pulse width modulation. So this is going to go to the general ground over here. Oh, gross, dirty fingernails. Come on, man. We're gonna go from the negative pin to the center pin on our, so negative rail to the center pin on our potentiometer. I don't understand why, but that's okay. we're gonna figure that out. And then this goes into the negative of our potentiometer and into our negative for our buzzer. So our buzzer has a nice circuit there. With our positive coming in yellow. I see that Leading Musicians is posting. Even if you know someone's username, Leading Musicians, you should usually refer to them as what you see in chat. So if you see his name is V.E. Kruger in there, I would probably stick with V.E. Kruger as well, just based on people's identities and things. And in Twitch, it's sometimes good to just use the same username. Welcome to the show, though. Appreciate it. So we've got that all hooked up. No problem. Glad you could join us. So we have everything hooked up, I think. So, oh, it does say something. It says, I was curious about not seeing a positive on the potentiometer. It says, notice that only 2 of the potentiometer's legs are used in these circuits. The potentiometer is acting as a variable resistor, limiting the amount of current flowing into the speaker and thus affecting the volume as you turn the knob. Doesn't really explain it. So I'm gonna have to ask Zen about that one later. But I guess it kind of makes a little bit of sense. Still weird to me. I would have guessed you would do the top and bottom pins, but okay. So let's open up the Arduino IDE. I'm gonna move this box over here. Hopefully it didn't tip over. And we're gonna open up our project. So I'm gonna go over to File, Open. Go up, we're doing Circuit 2A Buzzer. We're gonna open this up. And just because it's starting to drive me a little crazy, I'm gonna close all of the other projects that I have open. Because that's it's bad form. So, okay. So we're gonna play notes using a buzzer connected to pin 10. So we're saying pin 10, integer speaker pin equals 10. So here we're creating the variable of speaker pin. Doing setup here. So we're saying pin mode. We're using pin 10 or the variable speaker pin as the output. And here's the loop. Oh, this is going to be fun. Void loop. So how does it know what those mean? Oh, it's an array. That makes sense. Okay, so here we have, it's playing 2 Gs. Let's get that song. Okay, so I wonder if this is minor and major or something like that. Okay. I guess I could read the instructions instead of just trying to muscle my head through it. Play character notes. Notes are C major. There are no sharps or flats. This array is used to look up the notes. Character notes. Oh. Here's some frequencies here. I'm sure there's a table for frequencies somewhere that I could just grab. So, okay. Let me do this upload here. So, upload. I feel like this thing might start screaming happy birthday at me soon. Not sure. Ah, neat. That's wonderful. And I bet I can hit the reset button and it starts over. Nice. That's hilarious. Okay. So, okay, so here we have this number here, and this is an array as well, right? Because this is the note and this is the number of happy birthday to you. Yeah, so this is the how long the note is, and this is the note itself. Okay. Just gonna keep doing that for a second. So here it's showing us, so this array is matching like so. Here are the notes that have to do with these frequencies. Okay. So we could just picture this as a table of notes then. I wonder if they even have that in here. Oh yeah, okay. So they did have this in here, I just missed it. So these are the notes being used here. So we can see them all as such. Guess this isn't all of them, this is just some of them because we have a number of different notes here. So I'll definitely, if I'm going to be doing anything else with tones, I'm going to want to pick up, like I'm sure there's some kind of table we can look up online that's like Arduino frequency notes, Arduino buzzer frequency notes. Let's see if there's a cool guide. Neat. So, as with a lot of things on the internet, it's nice when we can find a nice little guide for it. That actually didn't show us what we wanted, but seems as though it would be easy to find. That's cool. Neat, neat, neat. Okay, so here's our frequencies. So if we want to do, we have different octaves and stuff here, cool. Let's see what it tells us to do next. Okay, so some things to note in the code. Character variables. The char or character variable stores character values. In this sketch, the play function gets passed two variables, a character variable that represents the musical note we want to play and an integer variable that represents how long to play the note. A second array takes the character variable and associates a frequency value to it. This makes programming a song easier as you can just reference the character and not the exact frequency. Cool, so yeah, we create the array here ahead of time for the frequencies and match them with the notes. So beat length. So we could change this and we could really slow it down. So if we say this is like, let's do 300. This is essentially like the tempo, I'd guess. So if we change that, this beat length should, yeah. So now everything's takes twice as long. Now it's kind of like a slow derpier happy birthday. I don't know, is derpy really a thing to say anymore? I don't know if it is. I don't know if that's a good word to use. Maybe a slightly drunken happy birthday. That's probably better. So tone function. Tone function will pulse power to a pin at a specific frequency. Duration controls how long that sound will play. Tone can be used on any pin. So let's find that tone function. So character notes, int frequencies, tone, okay. Play the frequency that matched our letter for the number of beats passed by to the play function. So tone, so we do speaker pin, so that's just 10. Current frequency, let's find where that variable is. Just trying to find it here. So int current frequency equals 0. Okay. So this is what's going through the array, I believe. So for I'm gonna need Zen for some of these. If notes I equals note. So this isn't explaining this too well, but might need to just continue and see what it does. To declare an array, you must give it a name. Oh, Zenhavr. Oh, just in time. I'm not understanding this array function and like how this all works. So I understand that this is the array. Thank you for joining tonight, by the way. I've only said a couple times, I need to ask Zen this. So I have the array here. So I'm not understanding why it's setting this as 0 initially. It's setting the integer for current frequency to 0, unless it's mostly just like declaring this variable as an integer and then setting it to something, it doesn't matter what, just to start off. I understand beat length. We already played with that a little bit today. I'll set this back to what it was. We're creating a little happy birthday machine. It is hilarious. I enjoy it already. But I'm not understanding really how this for loop works too well. Okay, so you should set it to some value as a default, not just declare the variable. Okay. So when in doubt, just set something to 0. Maybe, is that a thing? If notes I So this is really just like double checking, like, are you, so this is gonna not do something silly if I put like an R in here. Doing that, this is not gonna work because of this if statement, making sure because there's no note going through there, right? But why is it adding, oh, is it just sending us through the lines? Is this just saying to like go down the list of lines, or? This is the part that's confusing me, because that means to like go one more step, right? I'm not sure. For loop has 3 entries separated by semicolons: initializer, conditioned, and post loop action. So initializer, oh, this is the initializer here, right? This is like for while this thing is happening. I guess it's not while. Just don't understand that. I apologize that I'm asking like 100 questions all at one time. I'm going to take a drink of water so I stop talking as you answer this. I feel like I want to just like bribe you. Maybe I could bribe you to join me on like a Hangouts call at the same time or something like that. I feel bad having you to type with you typing all this stuff up. I should change this back from R to A. Set a variable equal to 0. Okay, so set the variable I to 0. Okay, I understand that now. Okay, that makes sense. Each time through the loop, check if this is less than num notes. So num notes. Oh, excuse me, it's 14. Okay. So, okay. Check if it's less than num notes and fail the loop if it is false. Add 1 to I at the end of each time through the loop. So the purpose of this for loop is to iterate through all of the values in the array notes. Okay. Where else is num notes? Okay. Yeah, no, okay. I think I'm getting it. Okay, this is good. Thank you for that explanation. I appreciate that. Okay. So if we set this to, set this to 7, then this will only play half of our song, I believe. No, because this doesn't match the number of entries in my array. So this totally screwed up the array, I believe, right? Interesting. This for loop will essentially loop 14 times. Each time it loops, there will be +1 from the previous loop. And that's what this plus plus means, right? I believe I've seen this before. Okay, that's making more sense. So, okay, I get this too. Beats times beat length. And this beat length is set here. So the I++ operator is functionally equivalent to I equals I plus 1. Okay. Yeah, I've used that before on some of the browser scripting that I've used. So beat length is 150, that's milliseconds. So down here we have, right, so beats times beat length. So does it say where tone has, okay, so tone has, the tone function requires 3 different things to be set: pin, frequency, and duration. Okay, that makes sense too. There's our delay. Okay. Oh, cool. They have a whole chart of notes in C major. That's cool. That's some nice documentation. Okay, I think I understand this one. Thank you for explaining that loop for me. I think we're ready to move on. Looks like the purpose of the function is to translate a passed note into a frequency. Yeah, I think that's what they're trying to. They're trying to make the actual song programming a little bit more friendly by putting the length of the beat next to the note itself. Yeah, right. Because I could just as well have done this with, I could have done this without this and just put the actual frequencies there, but it would have been less easy to read. So yeah, this loop is just for proper labeling. So, and what I like about this is that I know that there's a lot of pieces of information out there that are already in tables, right? They're already in tables and ready to be created as an array pretty easily. So I worked a little bit with arrays when I was doing a Python course, but I never actually finished that. So I'm not 100% on arrays, but we're getting there. This is at least familiar to me somewhat, so it's not all completely foreign. I think I'm ready to move on to the next one. Because now that I understand all of the intricacies of this loop, I say as I have to stare at it again for a little while. Yeah, this is one of them where and I think this is going to be increasingly the case, where the software part of it is kind of more of the mental puzzle than the hardware part. So I think thinking about not ever in existence. This is just my first for loop with Arduino. I've done a lot of while and for loops and like ors, all so the standard operators, I think they're called, right? Standard operators in Excel and in I've done these in Excel and in my browser scripting tool. They're not second nature to me yet, though. I'm still kind of struggling a little bit through, especially some of the while stuff, but this is just, I think, written out in a way that I'm not super used to, I guess. Or I'm getting thrown off by all of the commenting on the sides or something, but you know, what's kind of getting to me actually is how it's C major. That's funny. Pete Kruger said, LOL, I misread the document there. I thought maybe C major was a new coding language I was unfamiliar with. That is funny. Yeah, C sharp and C major. Goodness. So one of the things that's throwing me off here is that I feel like they're declaring variables in a way that doesn't make very much sense to me. For everything that I've done so far, you declare all your variables ahead of time, or you're kind of a little more intentional about them. And I'm feeling like some of these variables are being introduced along with other things, and it's a little confusing to me, I guess. So maybe I'll get more used to it. I don't know if that's just a part of this, or if it's just the way that this was developed, or if all the other stuff I've encountered is just a little more strict or something. But anyway, yeah, I guess that's what I'm used to, is just declaring a whole bunch of variables at the start. You know, I like to start off with a list of, okay, this is called this, this is called this, this is called this, and then go into all of the loop functionality. I'm going to start pulling wires out of this one. Let's set these aside. Is it best practice is you declare variables as close as possible to where they are used? Okay, that's good to know. I always like knowing best practices, especially when it's just me learning a habit maybe in a bad way. So I appreciate that bit of insight. Zenhavr. So you want to declare, there's also meaningful distinction between local and global variables in some languages. Okay. V.E. Kruger, could you explain more of what you mean there? Velcro. Okay, I need the potentiometer, I've got that. Piezo buzzer, got that. We need 3 push buttons. Oh, I'm sorry, everyone. Music. For embedded systems, it can be important for variables to be allowed to go out of scope so that the memory that was allocated for them can be reused. Okay. So, for your example, couldn't declare a global variable inside a specific procedure in SAS, but you could declare a local one. Downside is that the local one cannot be referenced outside of the procedure. And that's kind of what you're talking about as well, Zen, is that if it's a variable within an embedded thing, within an embedded system, once you leave that embedded system, it dumps it out of the memory, maybe? Okay. Upside is that you can duplicate one procedure so that you have one I variable for each procedure. Okay. Without having to do I1, I2, I3. Okay. So if you're creating like a group of procedures, it's best to kind of keep them compartmentalized. Is that maybe a reason why you would do it like that? Okay, counter jumper cables. Yeah, though in the context of embedded system means system with a microcontroller. Okay, so I was maybe misusing it, thinking about like a variable that's embedded within a particular function, a variable inside of a function as opposed to a variable outside of a function. And you were referring to embedded software. Okay. Okay, cool. Kind of clicking a little bit. Okay, so new components. Buttons, also known as momentary switches. Buttons only remain in their on state as long as they're being actuated or pressed. Most often, momentary switches are best used for intermittent user input cases. Reset button on the keypad buttons. These switches have a nice tactile, clicky feedback when you press them. You ready? I don't know how loud that was. You can hear that. It says can OBS hear it? Oh, that's quite loud actually. There's my clicky button. Note that the different colors are just aesthetic. All the buttons included behave the same, no matter their color. That's great. New concepts. Binary number system. Number systems are the methods we use to represent numbers. We're most used to operating within the comfy confines of a base 10 number system, but there are many others. The base 2 system, otherwise known as binary, is common when dealing with computers and electronics. Computers, at their lowest level, really only have 2 ways to represent the state of anything, 1 or 0. Which can also be thought of as on or off, true or false, high or low. Almost all electronics rely on base 2 number systems to store and manipulate numbers. The heavy reliance electronics places on... Let me reread that. The heavy reliance electronics places on binary numbers means it's important to know how the base 2 number system works. This is gonna break my head. We're gonna try though. This is my first time really doing anything with binary, so we'll see. Zenhavr, how much do you actually work within binary? In the base 2 number system? Welcome to hell! Oh, good! Great! Can't wait! Very extremely often. Alright. Great. My hands just got sweaty thinking about it. Okay, we're also going to learn about digital input. In Circuit 1A, you worked through digital outputs. Each of the 14 digital pins can also be digital inputs. That's cool. Digital inputs only care if something is in one of two states, 0 or 1. Digital inputs are great for determining if a button has been pressed or if a switch has been flipped. We're also going to learn about pull-up resistors. A pull-up resistor is a small circuit that holds the voltage high, 5 volts, on a pin until a button is pressed. Pulling the voltage low, I guess that's the sentence. That doesn't make a lot of sense to me, but the most common place you will see a pull-up resistor is when working with buttons. A pull-up resistor keeps the button in one state until it is pressed. The breadboard has built-in pull-up resistors, but they can also be added to a circuit externally. This circuit uses the internal pull-up resistors, covered in more detail in the code to note section. Didn't understand any of what that was. Also, base 16. I don't think I've heard of base 16. That's great. Is base 16 like hexadecimal? Is that base 16? Ah, hey! Cool. I did know about it. That's great. I know a little bit about hex. Okay. We're gonna start to build this thing. I'm gonna pull these out. 0 through F. Oof. Yeah, I do use hex every day when choosing colors. Can I get some 15s in the chat? That's funny. I see what you did there. That's a very funny joke. That's good. What am I doing? Oh yeah, okay. Looks like I'm also recording. I wonder why I'm doing that. I'm gonna stop recording. Must have bumped that in OBS. All right, so plug her back in. Okay, so I'm gonna go to, you're in B, you're in H. Open up our, there are two kinds of people in the world, those who understand hexadecimal and those who don't, and those who overflow their one-based indexing systems. I don't understand. Oh, nice. That's good. Oh, really? I didn't know that. Just in case you lose the VOD. Yeah, I really super didn't understand that. You know, other than like thinking about it as like, you know, instead of a button going directly to a digital pin, like basically a button being a little floodgate that is constantly powered, and then when you press it, it opens it up. Is that kind of what it is? Pull-up resistor is just a button allowing current going through to an input. I'm so fortunate to have my friend Zenhavr on the chat. It's quite nice. So if you think of a button attached to a pin, and then attached to, say, ground on either side. Okay. When the button is not pressed, that input to that pin is floating, i.e. not attached to anything. What do you mean by either side? I guess there's four pins here, okay? It's not ideal. You want the input to always be set to either high or low, okay. That makes sense. Pull-up, pull-down accomplishes this by pulling the input high or low until the button is pressed, reversing the input. Pull up, pull down. Weakly pulls the value in one direction. That's not making any sense. Should I look up a diagram on the internet? When you press the button, it strongly pulls it the other way, overriding the weak pull. I'm gonna put this together. Well, no, let's find something. So we want to look up. So I can't see this and not think Marvel Comic Universe. This is a microcontroller, right? Oh, sorry, not sharing the right screen. To think of the two possible states of the switch, either open or closed. So, I mean, if that switch is closed, so then it should be getting probably the full 5 volts through the button, right? Versus when it's open, maybe it's not. I don't know. When open, what you have is the line tied to either high or low through resistor. Okay. So does MCU have its own like kinda ground and kinda positive? That then just gets more when you close it up? I don't know how that works with the... Okay, so actually when I think about this, that does kind of raise a question about this diagram and what I'm setting up here. Because if I look at this, then when you close the switch, you have a direct line to ground. Yeah, because I was going to ask about... There would be positive... No, there wouldn't be positive and negative coming through, but like, does this negative up here, this ground up here, have an effect on these at all? Or is it just choosing the path of least resistance up here and this is all going to stay in its own little place? Or is there actively going to be some grounding out happening up this way? When you close the switch, you have a direct line to ground. So yeah, so this is 5 volts. Breadboard is not connected through the holes in that way. Oh, okay. I didn't realize that. Oh, so it's not up and down, it's just side to side. That's right. Up and down is only in these rails over here. So it's providing 5 volts to these colored lines here. I don't understand. I don't get it. I'm gonna build it and we'll look at the code and maybe it'll make more sense once I do that. Is that a good thing to try? I can look at how it's being coded. Because as it is now, I mean, it kind of seems just like maybe we look at like this one here. I don't know. It's moot in this circuit diagram because it looks like they're using an internal pull-up, pull-down resistors in the red board. Oh, okay. So the input about the information about pull-up, pull-down resistors was to confuse and distract me. I see. Let's build it. Okay, cool. Yeah! All right, I like that. So I'm gonna move this over here, move this over here, and we're gonna zoom in. Oof, that's not where I want it to be. Okay, so first step is let's hook back up what we had before. We, for some reason, took apart. I'm moving this over again because there's really not enough room to get at these pins with these in the pins they're recommending. So I'm going to move these over because I don't think it matters. Just going to give myself some extra space. So this goes to the top pin up here. This goes to there. This goes to F. This goes to pin 10. And I really do appreciate that you're taking the time to watch my stream here, because you are extremely helpful when trying to figure this stuff out. It would make it significantly more difficult for me not to have your assistance. We could totally do that whenever you want. We could set one up right now. It would take like a minute. But we could also do that at a later date. Would be fine too. All right, so got that circuit all hooked up to the ground. Yeah, it would be, I think it'd be probably just less typing for you, is my guess. Would you want to do just a voice call, or do you want to do a video call as well? Yeah, I think so. So we're gonna try. Oh, Hangouts needs microphone. I'm gonna email you a Meet thing. That's not what I wanted to do. We're not joining that call from 2 weeks ago. That was silly. Okay. All right. So I'm gonna probably turn off the music. And I'm gonna turn up that there. Let's see if this can work. So I did send you an invite in Hangouts to join my Google Meet. There we go. Hello there.
Oh.
Yeah. Do you want to throw a couple tests in there?
1, 2, 3, testing. I had to go mute your stream.
Okay, so I'm going to, and you can still hear me okay through the Hangouts and stuff?
Yes.
Cool. Thank you for joining us, Zenhavr. Anyone else in chat? Zen is a bit low. Okay, so let me... Okay, so I'm going to turn up that. And... Zenhavr, would you mind testing a little bit as well?
Testing 1, 2, 3.
And V.E. Kruger, how is that? Is that a little better?
I am speaking, and this is my voice.
Perf. Cool. Hey, this is fun. I'm excited about this. All right. Cool. Thanks for joining the show, Mr. Zenhavr.
Yeah, glad to be here. Probably be a bit easier on my fingers.
Yeah, I believe it. I would be, yeah, right. I would be, if I were trying to communicate this stuff, I would be speech to texting it, and it would come across all weird. So I appreciate all of the effort you put into typing.
Sure thing.
I usually don't put in that effort to typing. I'm sure it's noticed. So thank you. So I'm just gonna keep on hooking this stuff up. So it introduced the concept of these push-pull. God, I already forgot what it's called. My gosh. Push-pull
Pull up,
resistors.
pull down resistors.
Pull up, pull down resistors. Thank you. But it's just doing it itself. It just has them built in.
Yeah, I think it alluded to that in the instruction manual that the red board has internal pull up, pull down resistors on every single digital input and output. But
Sure.
it was saying that you can wire them up externally, which you would need to do anytime your electronics don't have that sort of internal functionality.
Would that be with like a they make some like mini Arduinos, don't they? Like some really, really small ones that don't have all of the fancy bells and whistles?
Yeah. Also, anytime you were using like a button or a switch, and then using that as an input to something other than like an Arduino, like if you were using it to control like a transistor or some kind of discrete electronics component that
Okay.
wasn't an Arduino, you would need to use a pull up, pull down.
Sure, if it has a digital input?
Yeah.
Or if it's using digital, okay.
Yes.
So I wouldn't need any of that for like wiring in my truck.
No, I guess it depends on the circuit itself, but I
Sure.
would say probably not.
Gotcha.
Because what a pull up, pull down is doing is it's sort of setting the default value on the digital input when the button or switch is not being pressed or activated.
Sure, and what happens if you have that floating thing that...
It is, it depends entirely on like the microcontroller itself, because like the behavior of that pin on a microcontroller is, what's the right word? It's not deterministic, or it is entirely up to the actual silicon itself, like how the microchip has been fabricated and designed. dictates what
Oh.
happens on a floating input. But a floating input is one of those sort of quote unquote, in all capital letters, very bad thing that you avoid at all costs because it's not a predetermined state.
Sure. What kind of havoc does it cause?
Well, it could theoretically like flip back and forth between high and low at a very high rate. It could cause like a flip from high to low, just based on circuit noise.
Oh, wow.
Like power rails, when they are powering something that consumes a lot of current, can cause some noise to ripple through the system that could cause floating inputs to switch between high and low.
Could that mess around like if you have like any electromagnetic field stuff interfering with that too?
Yes, absolutely. If you had any sort of magnets or even some some like inductance in the system, it could cause those floating inputs to switch.
All capital letters, very bad. I like that. Yeah, because then your whole thing is completely unpredictable. Okay. Okay, that's good to know. So, oops. So maybe we'll look at the circuit one more time, the circuit diagram, and you could walk me through that one more time. Let me just find where I put that. Okay, so maybe we'll try this once more before moving on. So can you explain to me this diagram a little bit?
Sure. So let's just look at the pull-up resistor now
Okay,
and ignore the pull-down resistor because the mechanics
sure.
are the same, but it's kind of hard to talk about them both
Cool.
generally.
Should we look at this one instead then?
Um,
No?
the other one you had was just fine.
Okay, sure.
So I was trying to allude to this when I was typing. Let's look at the pull-up resistor side of things and think about the two different states that the switch could be in. When it's open, i.e. the switch is not activated or the button's not being pushed, just
Mm-hmm.
completely ignore that little leg that goes down to ground.
Yep,
What you have is a line that's tied to 5 volts through a resistor. That's going
yep,
to set the input to that pin to be high
yeah,
when the switch is not activated. So that's what's quote unquote pulling up the input.
okay.
Does that make sense?
Yeah, okay, so it's high because there's a ground in the MCU, right?
It
At some point.
yes.
Or
It's
it's feeding voltage into the MCU.
yes.
Okay,
Well, yeah. Think of it less like it's feeding or draining voltage and more just like the MCU can see that it's at 5 volts or that it's at ground and uses
sure,
that to determine whether it's high or low or true or false,
sure.
1 or 0.
So what would be the not pull up resistor version? Like what's the wrong way of doing this then? Where would the switch be?
Basically, eliminate from your mind that entire leg that goes up,
Yeah,
that has a resistor in it. You basically have a line that goes to the input solely through a switch.
okay.
Um,
Kind of like what we're going to be putting together in the breadboard here, right?
yeah, yes, exactly. hmm
Okay.
Um, so then if we think about that other case, the more interesting one where you have pressed the button or flipped the switch so that it is connecting its two legs, then you have a circuit diagram that is essentially that line that goes out of the MCU and then both the line that goes up to 5 volts through the resistor and down to ground through a straight non-resistor line. So
Mm-hmm.
then you have a case where you have something that's trying to weakly pull it up towards 5 volts, and then you have it just tied directly to ground, which is a very strong
Yeah.
pull to ground. And so I'm trying to think of how you would describe this without getting too much into like like current like the actual like Ohm's law part of this. But
Sure.
you have the weak pull up to 5 volts and you have the strong pull down to ground, and the strong pull to ground wins and sets the input to ground.
So your resistor has to be enough ohms of resistance so that So it has to be more ohms of resistance than your switch when it's closed.
Yes, exactly. Yeah, that's
Okay.
exactly right.
So your resistor, so that's okay, that's making a little more sense.
In this case, the resistance of the switch when it's closed is 0 ohms.
Okay.
Um,
Switches don't have some of their own resistance?
no.
Or is it, okay. They shouldn't, at least?
Yeah, they shouldn't. It should
Right.
just be directly tying two pieces of metal together.
Sure. So so your resistor that you use for the pull-up resistor, what would indicate like what you'd need to put as a resistor there?
So I see a lot of the pictures here indicating 10K. That's a pretty standard pull-up value.
Sure.
It's important to choose something that's pretty high because um, when that switch is closed, in a sense, you are directly tying the 5-volt rail of your system to the ground of your system, and
Yeah.
so current is going to want to flow from
Yeah.
5 volts to ground, and so you need a high enough resistor value so that the amount of current that does go from 5 volts to ground is very low.
Yeah. So you don't blow out your thing.
Yeah.
Okay.
So yeah, you wouldn't
That's
want to choose something like 100 ohms or 330 ohms. 10K is a pretty standard pull
okay.
up or pull down resistor value.
And that's 10K is common with a 5-volt system. If you
Yeah,
were to have a system that was a little bit higher voltage, like 12 volts, you would maybe want to choose a 20,000 amp resistor or something,
yeah, sure.
or 20,000 ohm resistor.
Yep. Yeah, because
Okay.
remember, according to Ohm's law, the amount of current that goes through that line is going to be the voltage divided by the resistance.
Yeah.
So if you had a higher voltage, it could be prudent to choose a higher resistor.
Yeah. Okay. This is starting to make sense. It is confusing that they introduce the concept and then say, "But don't worry about it."
What I'm going to guess is that in the code, there's a line of code somewhere that indicates whether you want that pin to be pulled up or pulled down. So the
Okay.
concept is probably important, even if you're not
Sure.
physically wiring it up.
Sure. Okay. That makes sense. Okay. Cool. I feel like I'm understanding enough to move on at least.
Very
Thank
good.
you.
I
That
will
was a
probably mute myself until you
until
try,
I have a
until you
question.
need something more.
Okay. Sounds good. Thank you. Um, music is probably pretty loud. Ba-ba-ba. Okay. Is music at an appropriate level now? Very loud for me. Okay. So, let's finish wiring this up. I got my green wire from a green button, and this is going to pin, looks like 2, 3, 4, pin 4. These, just a note, these buttons were really kind of a pain to get in here. I almost bent the pins on red here trying to get it in. It goes to 18. Oh no, I think I might be out of black wires. We're gonna switch to white for ground. Don't have to do monochromatic for grounds. That's what we'll do. Kind of getting the hang of this breadboard thing. Zenhavr, do you use breadboards at work? or is that kind of all done digitally at this point? You're doing actually like circuit design kind of stuff, right?
Yeah, I haven't used a breadboard at work, probably ever.
Yeah. Do you use like do you use anything like digital kind of breadboards or any like simulated breadboards?
No, not so much. A lot of the times, any software that I write, there's already been like a a circuit board created specifically for that piece of software, so I can just
Sure.
run the software that we're designing on the target system.
The target system. Um, and that's kind of the other part of electrical engineering that you elected not to get into, right? Is the actual like CAD circuit board design type stuff.
Yeah, I definitely learned a lot about that stuff in college with my electrical engineering degree, but I definitely went the software route.
And why? What encouraged you to go that route? You think?
Honestly, it was an Arduino that I bought like junior year of college that really like hooked me onto the software side of things.
Cool.
I also had some pretty interesting classes dealing with software and embedded systems that I really enjoyed.
So it was less of a distaste for hardware and more of just a strong liking for software.
Yes, I would say there's an extremely heavy math component to electrical design or electrical system design that turned
Sure.
me off a little bit from it.
Math is hard,
Math is hard.
and that's calculating a lot of the resistance and stuff, and like figuring out um how do
Yeah,
I like I guess all the electrical parts of it.
yeah,
That makes sense.
yeah. There,
It's like I hate saying really obvious stuff like that, but just trying to like think through like the all of the parts about the frequency and the Ohm's law and all of that stuff. I could see that being just a nightmare if you had to like actually math it out.
yeah. If you imagine like a complicated system with lots of resistors and transistors and stuff, every single one of those pieces of every single one of those components is going to have some current flowing through it, some voltage drop across it, and all of that
Mm-hmm.
is math and figuring it out.
Oh, goodness.
Yeah, I don't understand who in their right mind would actually enjoy math.
Yeah, I don't know. I can't think of anyone who would just choose to do elective math on occasion. This circuit is titled Digital Trumpet, and I like it. It's a good. It's just. Okay, so I've uploaded it, so we're good to go on that. Okay, so use 3 buttons plugged to display musical notes on a buzzer. So, okay. First key pin, second key pin, third key pin. That makes sense. Those are all wired appropriately. Buzzer pin 10. Yep, that's wired appropriately. Okay. Here's what you're talking about pin mode input pull up there. So it's declaring that there must be like a built-in variable into the system there. And maybe that's indicated by it being kind of a greenish color.
Yeah, that's the greenish color on this is indicating that there's a pound define somewhere in the like internal Arduino library that defined that value.
A pound defined, did you say?
Sorry, yeah, predefined
Predefined,
value.
okay.
Mhm. Pound define is the actual like code construct. It's like a pound symbol and then the word define.
Okay. Thank you. I invite the esteemed members of the chat to note the distinction between arithmetic and mathematics. Thank you, V.E. Kruger. Invite declined. Okay, set the buzzer pin as an output. Okay, that makes sense. Is there a list of all of these? I bet there is somewhere. It has it somewhere. You can look at all those different values. So if digital read first key pen equals low, tone buzzer pin. Oh, interesting. So these are constantly set to high then, based on how this is wired, because it's a pull up. Okay, so hang on. We gotta pull up our diagram here. So with the switch not pressed and not connected, it's going through the higher volt.
No, I think you got it. With the switch not connected, the default input on these pins is that they are going to be pulled high.
Yeah. So
if you wanted to check if the button was pressed, you would check if the input to the pin is low instead of high.
I guess in this diagram, though, I was expecting when the button wasn't pressed for it to be, well, I don't know. So the pull-up will be lower. Okay, so there still is going to be power going through to the ground, or to...
When the switch is not open, there is no electrical connection flowing through the switch, so it's basically as if there was no wire there at all.
Yeah.
So what you would have was just the 5 volts tied to the input of the microcontroller through that resistor.
Sure. It just seems like with the switch pressed, that should be the higher one because that's going directly to ground.
What do you mean by higher one in this context?
So if with it not being pressed, it's set to low, then when I press it, it makes me think that the voltage going through the system would be higher once I press the switch, right? Because it's going directly to a ground as opposed to going through a resistor.
Yeah, so when you press the switch, you're basically tying that ground to the pin. So then what the pin sees is ground.
Oh, okay.
Which is low or
Which is low.
Zero.
Okay. Okay. That makes more sense. So when it's not grounded out, it's seeing the high value because it's going directly up through the 5 volts. Okay. Thank you.
You got it.
Sorry. We have our little trumpet here. Thank you for clarifying. So here's our frequencies. Okay, that's really simplistic actually once you get in here. Compared to the last one, which had all the arrays and stuff, this is a lot easier to read. I'm not feeling like this is doing an adequate job explaining pull-up resistors. And I guess I could have read more carefully, but I definitely think like if we weren't on a call right now, each one of these things would take 45 minutes of YouTube videos to like understand some of these concepts outside of this toolkit.
Yeah, it's interesting that this manual, it kind of has to strike a fine balance between like fully explaining things versus just giving you the information you need to accomplish the goal. And it seems like since it's a beginner's kit, I would expect it to lean more towards the latter. Like it tells you this is things like pull up and pull down resistors exist. This is like a 1 or 2 sentence description of why you need to care, and this is the solution, without needing to get into the detail of, well, what is going on with the actual circuit design behind them. It's kind of hard to say.
Yeah, and it kind of does that. I mean, its description is like a couple sentences, but it still doesn't. Like, I don't understand why it's important. Like, I think that's the part that's, it says like, yeah, there's your pull-up resistors, and this is what it is, but it doesn't explain it all. Like, yeah, that's because if you don't have one of these two things, there's problems. So
That is true. That does seem like it's missing.
but that's okay.
It's like you'd basically have to by trial and error discover that floating inputs are a bad thing, which could take some time to realize
Trial
that.
and egregious error.
Yes.
Well, cool. Well, thank you for explaining all of that. I understand these tones pretty well. It's just really setting the buzzer here. If we wanted to, we could use the same array that we did last time to kind of create some variables for these tones, for these notes, but they're just using the frequencies directly here, which is cool. Can you make any note with this? No, I can't imagine that you could. Maybe you could. I'm not sure. Okay, we're gonna keep moving though. It's already almost 9:40. Can you believe that? It's amazing. Okay, so this was good. It seems like a lot of not much to understand the pull up and pull down resistors, and like here's buttons, and buttons seem to work with an Arduino without much goofing around. So that's good to know. So, question for you, Zenhavr. How do I know? Like, can I put any number of variables in this spot after pin mode, or is it restricted to 2? Or how do I know for some of these things what I need to put in this spot?
Great question. It depends entirely on how that function is defined.
Okay.
Anytime I don't know how to use a function, the first thing I would do is look at the documentation for it.
Okay.
I believe that the documentation for the Arduino library is very robust. So if you, I don't know, it would probably be as simple as like Googling Arduino pin mode function to discover what the appropriate inputs are for the
Sure.
function. I bet it would also give you exactly the predefines from the library that are supposed to go in certain fields.
So would that be dependent on what type of sensor I'm using? Or what type
Hmm.
of input I have
As
or
for like
output?
whether you want to pull up or pull down,
Pull up or pull down or put anything in this spot in general.
yes, yeah, it depends entirely on the application.
And, and then I would assume that most applications that I would be able to just get from a kit, would the kit tell me what to put in this spot or what kind of pieces to utilize for that? Or would it just say like this is this kind of sensor? And from that I would extrapolate what to look up in the Arduino library for it.
I see. So when you say sensor, you mean like an external
Yeah, I mean like
sensing
any of
component.
these, yeah, any kind of like, I don't know, like anything from this bag of goodies, or
Yeah, I would say there a lot of sensors that you'll probably work with aren't similar to buttons and switches. Like I don't
sure,
think a lot of sensors are going to be like opening and closing lines,
sure,
and that's really the instance where pull-ups and pull-downs are important.
okay,
Um, a lot, I think pull-ups and pull-downs are only important when you're talking about discrete digital inputs,
okay.
and a lot of sensors are more
The kind of
analog.
analog inputs, yeah,
Mm. Or if they are digital, they're probably communicating via like SPI or I2C or some other sort of digital communication protocol
okay, yeah, that makes
rather
sense.
than just like, yep, I'm going to put the input high or I'm going to put it low. There's really
Because
not much there that can convey information.
the analog ones are going to be sending um, between 0 and 1028, right? Or
They're going to be
1023.
setting their output between 0 and 5 volts,
Okay.
which then you would attached to one of the A0 through A5 lines that would convert that analog signal to a digital one, which the
Sure.
digital representation is between 0 and 1023.
Sure. Okay. That makes sense. Okay, thank you.
Sure thing.
So I'm going to pull all these. I'm going to unplug the power. I think we could just about get through circuit 2 tonight, which I'm pretty excited about. And I know I don't have to unplug these because this is probably going to use the same things, but I kind of want the practice of using the breadboard. Pile these over here. It's kind of nice just to like take the components out. And, you know, I'm going to see if I can leave these buttons because these buttons are a little bit tough to get in and out of there. We have our fourth button here. There's another component we're going to use. It's also asking us to use 4 LEDs from my LED stash here. And 4 330 ohm resistors. Which are these? Okay. So new concepts. Let's take a look at these new concepts. Get out of the way, Redboard. For loops. A for loop repeats a section of code a set number of times. The loop works by using a counter. Usually programmers use the letter I for this variable. That increases each loop until it reaches a stop value. Here's an example of a for loop. Why didn't they explain this in the first one? Gosh darn it. So that makes sense. We've already talked about that. That's cool. The for loop takes 3 parameters in the brackets, separated by semicolons. First parameter is the start value. In this case, the integer I starts at 0. The second value is the stop condition. This is the stop condition. Here. In this case, we stop when loop I is no longer less than 5. Final parameter is the increment value, I++. Is shorthand for increase by 1 each time. You could also increase by I by different amounts. This loop would repeat 5 times. Each time it would run the code in between the brackets, which prints the value of I to the serial monitor. Okay, measuring durations of time with millis. The breadboard has a built-in clock that keeps accurate time. You can use millis command, the millis command, to see how many milliseconds have passed since the breadboard was last powered. By storing the time when an event happens and then subtracting the current time, you can measure the number of milliseconds and thus seconds that have passed. This sketch uses the function to set a time limit for repeating the pattern. Custom functions. This sketch uses several user-defined functions. I love those. These functions perform operations that are needed many times in the program, for example, reading which button is currently pressed or turning all of the LEDs off. Functions are essential to make more complex programs readable and compact. You know, one thing I was just thinking about, Zenhavr, is that this one was like, oh, by the way, you're going to need to know about binary. And then we didn't learn a dang thing about binary or use it, really. What's the deal?
Yeah, that is interesting. I guess you could make the connection that a digital input being high or low corresponding to a 1 or a 0 in binary is the connection. Not sure though.
Yeah, I don't know. I mean, I'm happy to push that one, kick that can down the road until I need to know it, but I'm surprised. Maybe they get more into it in this next section or something.
Yeah, that's a good observation, though. It does seem like there's really very little binary that was actually needed for that project.
Okay. Hey, our circuit diagrams are getting a little more complicated. That's cool. Okay, what do we have here? Oh, this looks like fun. I'm liking this. So we have our 3 buttons. Let's put in our 4th button. This goes at D and G10 and 12. Gotta really push that in there. What's the when you have to like really press stuff into a breadboard like this? Is there a tool that people like to use for getting things back out? Is that like a needle nose pliers is good for that, or is there like a spudger pry bar thing, or is that a screwdriver's job?
It's a great question. If I had a component that was really stuck in there, I would probably needle nose plier it.
Okay. Or Nipex it because you always carry a Nipex in your pocket all the time.
Yep, or Nipex.
Nice. Better take that out over there. Okay. Cool. I suppose there is some risk of damaging a component though, using pliers, right?
Yeah, I would say that that's accurate. If there's ever like a resistor or an LED that's real stuck in there, those generally are pretty unlikely to get damaged pulling those out, but these buttons seem like they could have some small risk of damaging them.
Sure. Oh, okay. These are really nicely designed diagrams. I really like them. They're quite easy to understand. They do a nice job with like overlapping stuff. Well, let's get more components in, then I'll wire them. So here's a question then. When you're doing wiring like this, do you do like jumper lines and then components, or components then lines? Or do you try and like I'm gonna do this circuit at one time and then I'll work on this next circuit?
My personal preference is always components first, then wires.
Okay.
And if there is any possibility of breaking down the system into like different chunks of circuitry, I definitely like trying to do different parts all at one time.
So maybe I could do this for this diagram, doing the buzzer and potentiometer might be something good to just get wrapped up right away. It's kind of a standalone system up here.
That sounds great.
Okay. Okay, we'll do that. Get our ground in place. Bring this around. This actually makes it quite a bit easier for me to even see without getting my hat in the way and thus unfocusing the camera. So I can get that to line up correctly. So that's our ground to our rail up there. This goes to that pin for the potentiometer, down to this pin for the buzzer. Put this in pin 10. I've been tempted to get out my Mantis scope, my what is it called? It's like a dual vision microscope, right? I can't remember the word to describe that. But it's a microscope that gives you some depth of field.
Yeah, I can't either. I can't remember what the right word is.
It'd be fun to like hook a camera up into that. Kind of an interesting. It's almost too close though, right? Quite zoomed in. Okay, so there's our buzzer configuration. So we're on the middle pin for the potentiometer. And then, boy, these fingernails are dirty. And we have here's our 2 pins for the buzzer all hooked up. I'm gonna double check that actually and make sure I have my polarity correct. Looks like I do. Okay, groovy. Okay, next we are going to add in some LEDs. So I'm going to dump these out here. Okay, so we need a red, a yellow, these over here, green, and a blue. I have burnt out so many, I mean, I say so many, but it's probably like 6 LEDs in my past, just being like, I'm gonna hook this up directly to a battery, not understanding resistance or the need for it. Silly. There was a thing that was kind of popular online for a little while called throwies, where you just take an LED like this and hook it up to like a small battery that had the right amount of voltage or something. Maybe there's a resistor involved. You'd hook it up to a magnet. You'd like glue it all together with a magnet and a battery, so it was just on all the time, and you'd throw them at metal buildings, and they would stick and just be lit up LEDs. I don't know why this was a thing, but it was a thing. Like light graffiti. So here's the polarity. So okay, so we're doing the ground there. I think I'm going to hook up the LEDs in their entirety before I move on to the buttons. Those go in there. Red, yellow. Are you a person who likes to look at the flat edges or the length of the leads for LEDs to understand their polarity? Which do you find to be most effective?
I would probably say the flat edge, because a lot of times you'll clip those leads down to size for aesthetic purposes, or I have in the past clipped them to actually make LEDs fit nicely
Okay,
to places.
that's nice that they have 2 systems for that then. That makes sense to do that. Yeah, because I mean, if you're like soldering them to stuff, you're not going to have the length of the leads to tell you anything.
Yes, exactly.
I don't understand LEDs enough to know why they have polarity. Like it's confusing to me how you have some things with polarity and some things without.
Specifically for LEDs, so LED stands for light
Light
emitting
emitting diode, right?
diode, and diode is the important word there. A diode is an electrical component that only allows current to pass through in one direction.
Okay.
So LEDs specifically are fabricated in such a way that when current passes through that diode, light is created. And so if you were to try to apply current reverse across an LED, obviously that diode is not letting that current pass through, and thus no light is generated.
Gotcha. Can you use that then for, so diodes are typically used so you don't have like weird back current problems, right? Like current doing silly
Yes.
things.
Yeah.
Are LEDs used as like, well, looks like I don't have any diodes, might as well just use an LED here instead? Is that a thing that happens, or would you use like a regular diode for more of a diode-y situation?
That is a great question. I cannot say for sure whether a light emitting diode would be appropriate to use in place of a regular diode. There might be some funky characteristics of an LED that makes it unsuitable for that application, but I cannot think of any. That would be something to look up.
Nice. I will do that. Like, I feel like you'd run into like, I'm sure diodes, like proper diodes, are a lot more, have a lot more, I'm getting out of order here. Proper diodes have more that they can handle, I'm sure, right?
Certainly, you don't need
kind
a
of,
current. You don't need like that current limiting resistor with a regular diode at all.
yeah.
Regular diodes can handle a large amount of current through them.
Okay, so this is what they're doing. I understand their color coding here. It seems like this color coding kind of stuff is very much just like a, you know, if you feel like it, color code. As long as you follow, like, I wish I just had more black wires for grounds, but the other color coding doesn't seem quite as necessary. Oh, cool, they're doing it in pairs. Okay. So they're not putting all the LEDs together and all the buttons together on the inputs and outputs. They're putting them next to each other. So blue is next to blue and green is next to green. Which is a little confusing based on the way that I'm putting this together. But I'm sure if you were like, I'm going to wire up all the blue stuff and then I'm going to wire up all the red stuff, it'd make a little more sense. Every other, and I am ending up on 2. Okay, yep. Okay, so all the LEDs are hooked up. Next is to hook up my buttons. So do here to here. Do some of these kits come with shorter jump cables? Or is jumper cable the right term here? Or should I use a different term for that?
Jumper cable is exactly the right term to use here.
Okay.
There definitely are some pretty dang short jumper cables that I have seen in this style with like little rubber grippies on the end.
Which are really nice.
They are extremely nice for breadboarding.
It's really kind of fun to use resistors here in a not just for LEDs. Like, I think that's one of the more interesting things in this project that I've enjoyed, or in these projects, is just that, you know, understanding that resistors aren't just so you don't blow out your LEDs. They serve some other purposes and actually are very much required to make things function.
Yes, they're one of the big 3 components of discrete electrical circuit design: resistors, capacitors, and inductors.
Inductors. Ooh, I don't know anything about those. I wonder if we'll learn about inductors in this kit. I'm definitely feeling a lot more comfortable with this breadboard than I was expecting to. Now that I've been playing with it for a while. I think unhooking everything and hooking it back up definitely helps. I'm going to say that and then it's not going to work because I plugged it in wrong or something. But we'll see. Given these rubber things on the ends here, there's actually like almost not enough room for all of my jumper wires here. I have to like kind of jam them in place because all of these are being used right next to each other. But that's fine. Okay, I think this is all hooked up. Just re-looking at all this. Okay, yeah, we're good to go. So here we have our whole setup. So these whites here are used for ground because I didn't have enough black wires for ground. Then I have red for the button here, red for the LED, yellow for the button, yellow for the LED, green for the button, green for the LED, blue for the button, blue for the LED. So we are prepared to start looking at our software. I'm going to plug this in. I'm going to go to open. Simon Says. Now, one thing is concerning to me is that I'm like powering it on and it has the old software on it, right? It has the old software until I hit the upload button on this new piece of software. And my gut says that I could do something really bad to my hardware by putting in the wrong software, right? Is there another way that I should be going about this? Like I should be clearing the cache or something like that before I plug it in?
You know, that's a really good thought to have. I would say generally with an Arduino, it's pretty hard to screw things up as far as the breadboard goes.
Sure.
But it does kind of seem like you could have like something hooked up in a reverse polarity kind of situation that would
Yeah.
damage it if you were to run the old software. So I don't have a good answer for that.
I'm gonna unplug this. I'm feeling like I guess it doesn't matter too much because they are connected in the system as well, but I'm just pulling my LEDs over a little bit because they're kind of close to the resistors where the bare wires could be touching. So I'm just pulling these over to the side so that everything is a little more. Yeah, it just seems like could be like a best practice thing is like you don't want to run bad software on it. So I could see doing something like having a blank sketch open that I then click upload on when I'm done. Just to upload nothing to it before I upload the next one, before I hook up the new system.
Certainly, if it was really, really important that you very tightly controlled what was happening from the breadboard, you could think about doing that.
Sure. Not likely.
Seems pretty unlikely to me, but something to keep in the back of your head.
Now this yellow LED is not working. I think it might have been recently, unless I just don't have it plugged in right. Oh, my jumper wire is maybe grounding out or doesn't have a good connection in the breadboard. Let me plug this again. Use a different pin, maybe, or a different slot in the breadboard. Okay, yeah, it looks like it's working now. Okay, so Simon Says game flashes a pattern using LED lights. Then the player must repeat the pattern. The sketch was written by SparkFun. Dee-dee-dee-doo. Okay, set the pins where the buttons, LEDs, and buzzers connect. Okay. Into button. So is this an array here? What are we looking at?
Looks like it's defining a static array. Did you connect the buttons to pins 2, 4, 6, and 8 on the red board? Is that
Yep.
what those values mean? Okay.
Did. So this would be button, the first button would be red at 2 pin, and that would be into button, 0, right? Yeah, red is button 0, okay.
Yep, it looks like it's trying to assign sort of a semantic meaning to the pins by saying
Sure.
like red is the first position in the button array, yellow is the second one, etc.
Okay. Thank you. Same thing with LEDs. Here's our 4 tones, C, G, E, and B. Okay, rounds to win 10. Number of rounds the player has to play before they win the game. The array can only hold up to 16 rounds. Int button sequence 16. Make an array of numbers that will be the sequence that the player needs to remember. And buzzer pin 10. Okay, that's the buzzer. So integer pressed button equals 4. A variable to remember which button is pressed. 4 is the value of no button is being pressed because there's only 4 buttons, and this would be in 0 indexed 5. And round counter 1 keeps track of what round the player is on. Is this 0 based or not?
Looks like no.
That's tricky.
It is tricky.
Long start time 0. Timer variable for the time limit. Buttons press. Time limit 2000, which is 2 seconds, right? 2000 is 2 seconds. Or is it 20 seconds? I can't remember.
That's 2 seconds. It's in
Okay.
milliseconds, I assume.
Yep. Okay. Cool. Learned about that already. Set LEDs, pins to output. Okay. So here's another general question for you, Zenhavr. All of this stuff that is above void setup, why choose to put this stuff up here and not in the setup?
Because you need all of these things in both setup and loop.
Oh,
And
okay.
so variables only exist in the scope in which they're declared. And so by putting them outside of setup and loop, you've scoped them to be global from setup and loop's perspective.
Because setup and loop are just functions.
Correct.
Okay. Gotcha. I'm glad we already talked about global and local variables. Yeah, thank you. I'm glad we already talked about that a little bit. V. Kruger says, a new video game idea. You roleplay as a variable. The game sends you input and you have to remember how to store them correctly regarding various inputs. That's funny. That's good. I'm thinking of like different movies and games and stuff where you play as like a certain kind of cell or something in a body. It's kind of an interesting thing. Just a anthropomorphization of a variable. That's funny. I like it. Good idea, V. Kruger. Okay. So all this function stuff, all this stuff that's in function setup, why would they put that as in a separate function as opposed to just outside of the functions? Just to keep it more neat?
How to explain it? You can't call functions from outside of functions. So everything that's in the area where everything that's in the area where you're declaring the global variables, none of that is actually. I'm struggling to think of the right word. None of that's not a space in which you can call functions.
Sure. And setup is like a specific predefined function?
Yes.
Okay, so you couldn't declare your own functions outside of setup or loop?
You can create a new function anywhere in here that you could call from setup and loop.
Okay.
You just can't like put a function call outside of these two functions because it wouldn't. There's nothing that would execute it, essentially.
Okay.
I don't know if that makes sense or not.
Mm-hmm.
If you think of the Arduino system as a whole, basically there's some higher level part of this code that basically all it does is goes and calls setup once and then initiates an infinite loop to call the function loop over and over again.
Okay.
And so, yeah, all of your executable code has to go somewhere inside of setup or loop.
That makes sense. Thank you for answering the question. Okay, so here's our loop. So here's just setting all those things up. Okay, so let's see how big this is. Well, it's hefty. Okay, so if game started equals false. Start sequence. The game hasn't started yet. Flash the start sequence. Reset the round counter. Wait a second and a half and set game start to true so that the sequence doesn't start. Start again. So it's an if statement that kind of goes through and turns itself off, right? Just a loop that at the end of the loop it turns itself off.
Say that again.
So this if statement turns off itself at the end.
Yeah.
Okay.
Mm-hmm.
Just a little reset thing. Okay. Each
I
round.
notice round counter is set to 0 here. Is that the same variable before that we were confused on regarding whether it was 0 based or 1 based?
Yeah.
So it seems like this setting it to 1 was sort of a red herring because it goes and sets it to 0 right at the start anyway.
Yeah. That's weird. I wonder if we'll run into it again. Well, here's the round counter here. Each round, start by flashing out sequence to be repeated. It's already 10:15. How did that happen? I'm gonna blame daylight savings time. So flash is a sequence for whichever round it is. Flash LED button sequence I. So it looks at the array with the different button sequence, turns off all the LEDs. Start going through the sequence one at a time. See if you, so, one more question. It's calling an array that's a function that's kind of put together after it's being called. Wouldn't, if I mean in like Python, I think, don't you have to declare all your functions and stuff before you enact them? How is it able to call one of these functions, which is just the, you know, this button sequence thing, which is all the way down here, I think.
Yeah, there are definitely programming languages where you need to declare a function before you use it. C++ is not one of those languages. The assembler, or I should say the compiler, basically sees that you are trying to call a function like earlier up in setup or loop and says,
Sure.
oh, you're trying to call a function. I will remember that you tried to call this function here and I'll just assume that at some point later on you declare this function, and it goes and compiles all of the code, and then it gets to the place where you define that function and sees, oh, this is the function that you called earlier. Now I see the actual definition for this function. I'll go back and put this code or this this executable code in that spot where you called it earlier. And if it fails to make that connection, or if it fails to like find a
Sure.
function that you tried to call, it will report an error.
And it wouldn't have worked anyway because you wrote your function wrong.
Exactly.
Okay.
I also expect that there's some trickiness going on under the hood to make all of this a little bit easier in the Arduino system.
Sure. It's a little easier to digest.
In like true C++, you would need to have a specific line of code that states that you are declaring that this is a function, and then later on you would actually provide the definition for that function, but you don't seem to have to do that here. So I bet that the Arduino library sort of does that for you.
Sure. As opposed to like forcing you to actually do everything the hard way.
Yeah.
So I'm just trying to understand like how this game actually works. It's using a random seed, so flash LEDs, check which button is pressed, that makes sense. If read button is 0, set to low, return 0. Unbutton check. And then there should be something that's like, if button check equals 1, then turn on the LED or something.
Looks like the button check function basically will return a value 0 through 4 depending on which button is currently pressed.
Mm-hmm. And that can be passed into the LED or something like that.
Mm-hmm.
It's cool. It's using, so this is highlighted red for random seed and analog read.
Mm-hmm.
This is another kind of built-in something or other, right?
Yes.
I want
In
to
this
know
case,
what the other options are.
the highlighting of red probably just means that the Arduino IDE recognizes it as a function.
Sure.
Try Googling like Arduino random seed documentation or something like that. Yes, the Arduino reference. This is exactly what you're looking for.
Neat. Cool. That's neat. So I wonder, like, I'm just curious, like, there's a whole, ooh, nice. Look at that. All kinds of cool stuff. So these are the built-in functions and variables. Structure.
Pretty neat.
That's a bookmarkable right there. Okay. We're just about ready to, I'll probably wrap up here pretty soon. No, it's getting a little late. I am crap at these games, by the way. At the memory games, this is really a V.E. Kruger situation. He's especially good at them. Well, I imagine you're not too shabby yourself. Hi, yeah. How do you start the game? There's a win sequence. Pseudo-random. Go on. Please. Please be pedantic. I love pedantic.
True randomness is inherently unachievable in computer systems.
Yeah. It's an ATM machine. I just hit a button. It's going to take a lot more reading this code to understand how this actually works. I think with that, my friends, I think I might call it a night. This is a long enough little application here where I'm just going to have to stare at it for a while, I think. Like, I don't really know. think anyway. So this basically just starts with 0, and then every round it adds, probably just takes the round number. Yeah, okay, so it looks like it takes the round number, and that's how many random characters to add, but I don't know how it remembers what the previous ones
in
were.
this case, round function is
Oh.
rounding a number to to a whole number.
Oh, okay.
It's basically generating a random number between 0 and 4 and then rounding it to an integer.
Is this generating its own array? Is that what's happening probably?
Yeah, so it declared an array earlier on that was like 16, or no, it was you declare how many rounds you want the game to go, like rounds to win, and then it's randomly populating the array with a series of values between 0 and 3 in order to make the game random.
Oh, and button sequence, we know that this is initiating, or it's an array because of these square brackets, right?
Yes, so that's declaring an array that's 16 things large.
Okay.
And then that function in the start, or that for loop in the start sequence function, looks to see how long the game should be by looking at rounds to win, and then randomly generates that many values to put into that array.
And once it's reset, it resets that.
Yes.
That array.
Yes.
This would be difficult to come up with for me right now. That kind of back and forth connection like that. But it's interesting to think about having it populate arrays as it goes. You know, just thinking about building arrays with different analog inputs.
Yeah, up until now, I think a lot of this code has treated arrays as sort of static, unchanging sets of values, but arrays are really just memory, you know? You can declare an array and treat it as a regular old variable that you read and write.
You could have, you know, pull array values into serial or something, right? Couldn't you?
Sure, you could send an entire array over the serial port using a for loop.
Interesting.
That might be a fun a fun little project to insert here, to like each time it generates a new array of values that you want.
It gives me a cheat sheet.
Yeah, exactly. Just go look at the serial monitor and see what button you have to press.
I want to get this to a complete state, but I don't remember. I think I'm going to call this a night. Because we're a bit beyond when I was expecting to do this. This was, I think, I think they've all been it, where I get through to the end of the night and my head is a little full. But when I was starting off today, I felt pretty confident as to where I was. So I'm hoping that next week is the same story. I'm going to leave this all hooked up so I can kind of just retrace this. You think it's bad to press this down in here like this? All these jumper wires. Probably isn't that good for the board, huh? The brain array has been used up. That's right. Well, this was a whole lot of fun, Mr. Zenhavr. And
Agreed.
And VE Kruger as well. Anyone else who was on, hanging out, watching me learn Arduino. I think next week I would love to have you as a special guest once again.
I think that would be fun. I may even go so far as to create a calendar event for it so that I don't forget.
Oh, excellent. That's wonderful. I like it. Well, thank you, all you fine folks. Ooh, that wasn't a good sound. Thank you, all you fine folks, for joining me today, and Zenhavr especially. And I will see you tomorrow, most likely, for some The Long Dark. I'm going to be playing I might even play the Halloween special. I'm not quite sure yet. It's not actually out for Switch yet. They had some issues with getting the software updated on Nintendo. Another thing that I said I was gonna do, but I haven't done it yet, is my kind of 1 month late to Inktober, which I was going to be doing a bunch of illustrations. I got some stuff for that. I ordered a new set of field notes notebooks. So I'm going to be using this for my little sketchbook challenge. I'm not sure if it will hold up to the markers that I would like to use. I'm going to use some of these alcohol-based ink markers, which are super fun. You can do some shading with them. Yep. Had some troubles forcing the Dark Walker into the Switch. So I'm gonna be doing this. I can't decide if I want to do this as a stream or not with the sketching. I think I should. I think that seems like a thing to do. I'm going to do a couple test runs, I think, tonight. Maybe I'll get the first one done tonight and then try and have it be a thing as often as I can. There's a finite amount of streaming energy, of course, but it would be fun to do that. I did create a... Let me see if I can pull it up quick. I created a calendar in my Notion account. Let's see if I'm logged in here. I did. So, yep, this one's already due. Let me open this up. So I did create a calendar for the different things to draw. So this is my drawing calendar, things that I want to do. So tonight, I might still try and draw some canned peaches. So if I do, it'll probably be in... I might cheat and just do this one tomorrow morning, honestly, because it's already 10:30 and I'm a little sleepy. So I'm going to be doing this tomorrow. I think I'll have this probably during the day, probably around lunchtime, I think is when I'm going to try and do these drawings. So I will put some time on my streaming schedule for them, but keep an eye out for the alert. I'll post it to my Twitter account as well, which is twitter.com/_grantmakes. And it's in my Twitch profile. I'm going to call that a night. Thanks again, everyone, for joining. And I'll see y'all soon. Take care.